in this video we will discuss about the typical concentration terms. And the typical concentration term means these are typical in the sense that these are used for a particular substance. These are used for particular substance depending upon their use. Depending upon their use. And in this respect, the first typical concentration term we are discussing is the volume strength of H2O2. So how we can define the volume strength of H2O2? So we are taking an aqueous solution of H2O2 and H2O. So H2O2 is solute and H2O is solvent. So H2O2 aqueous on decomposition gives H2O plus half O2G. So very obvious, 1 mole of H2O2 will give half moles of O2. So the moles of H2O2 will be twice the number of moles of O2 from this equation. Also, we can say that the oxidation number of oxygen in H2O2, which is peroxide, is -1 and it is changing to the -2 and 0. So the N factor of H2O2, N factor is the valency factor which will be discussed in the redox reaction. N factor will be 2. Now, how we can proceed, how we can define the volume strength of H2O2. So volume strength of H2O2 can be defined as volume of oxygen gas liberated at STP from 1 unit volume of H2O2. So it is to be noted that volume of oxygen which is liberated by decomposition of H2O2, and it is to be noted that the volume should be 1 unit volume of H2O2 and the condition should be STP. So at the STP condition we will measure the volume of oxygen which is liberated from 1 unit volume of H2O2. If the STP condition is not given, we will use the equation of state P1V1 upon T1, that is equal to P2V2 upon T2 to convert the given volume at the STP, because this is the essential condition to define at STP that volume of oxygen should be measured at STP. Now, how we can decode this? Suppose if a bottle is labeled by VS or V. This is the bottle of H2O2 which is labeled by V or VS. So how we can decode this? We will simply decode this as V volume of V volume. Yeah, we can say that V ml of oxygen gas is liberated from 1 ml of H2O2 solution. So V volume of oxygen gas is liberated from 1 ml of H2O2 solution at STP. So obviously we can find the moles of oxygen, that will be V upon 22400 ml. And in the same way, because the moles of H2O2 is related with the moles of oxygen as twice, so we can find the moles of H2O2, that will be given as twice of moles of oxygen, that will be equal to V upon 11200 ml, right? Now, if we have the moles of H2O2, we can find the molarity and normality and percentage strength of the solution. So if the volume strength of H2O2 solution is given, we can find the other parameters like molarity, normality percent is W by V. We can say that strength in gram per ml or strength in gram per liter. So how we can calculate the molarity of H2O2 solution? For this, we can say that the moles of H2O2 is V upon 11200 ml. This is mole, and the volume of H2O2 solution is 1 ml. So 1 into 1000. On solving this, we will get V upon 11.2. So this is the relation. It is advised to learn this relation directly, that volume strength of H2O2 is related with the molarity as mH2O2 is equals to Vs upon 11.2, volume strength upon 11.2. Also we know that the normality is related with the molarity is molarity into n factor, and n factor, as we have discussed, that is 2. So the normality will be equal to Vs upon 11.2 into 2. This will give Vs upon 5.6. This will be the normality, that Vs upon 5.6 equivalent per liter, right? So we have calculated the molarity, we have learned how we can calculate the normality. Now it's turn to calculate volume strength. Percentage strength from the given data of volume strength. We know that the molarity of H2O2 is moles of H2O2, which is mass of H2O2 divided by 34. This is moles of H2O2 into volume of H2O2 solution in ml into 1000, and in 1000 I am writing as 100 into 10. So this term will be equal to the percentage, this term will be equal to the percentage W by V. So how we can relate the percentage W by V? We can relate that percentage W by V will be equal to molarity of H2O2, molarity of H2O2 into 3.4. We can say 34 will be divided by 10, 3.4. We can say that mH2O2 will be equal to Vs upon 11.2 into 3.4. This is the percentage W by V, and in a very simple way we can also calculate the percentage simply W by V, which is strength in gram per ml, that will be equal to volume strength upon 11.2 into 0.034. We can derive the same relation by using this equation. By using this equation. And if it is required to calculate the strength in gram per liter, simply we can multiply this by 1000. So what you will get, Vs upon 11.2 into 34 gram per liter. Let's understand some examples on the volume strength of H2O2. It is given that 10 ml of H2O2 gives 200 ml of oxygen gas on complete decomposition of H2O2 at STP. So first at all STP condition is given. Now 200 ml of oxygen gas is liberated from 10 ml of H2O2. So if you will recall this definition of the volume strength, as we have discussed, that it is a volume of oxygen liberated by 1 unit volume of H2O2. So obviously 10 ml of H2O2 gives 200 ml, because 1000 ml of H2O2 release 200 ml of oxygen. So we will calculate for 1 unit volume, and this will be 20. So the 20 will be the volume strength of H2O2. Now it is required to calculate molarity. We know that molarity is equals to Vs upon 11.2. So simply we can put 20 upon 11.2, and this will give 1.78 moles per liter. Now how we can calculate normality? Normality we can calculate directly, that normality is equals to molarity into n factor, which is 1.78 into 2. Directly we can write, or we can say that normality is equals to Vs upon 5.6. So 20 upon 5.6, it will make 3.56 equivalent per liter. Now it is required to calculate strength in gram per ml. So strength in gram per ml we can calculate is Vs upon 11.2 into 0.034. It is not percentage, it is simply percent strength. So we can put volume strength is 20 upon 11.2 into 0.034. In the same way, we can calculate the strength in gram per liter by multiplying this by 1000. In the next question, it is given that 10 ml of H2O2 gives 500 ml of oxygen on complete decomposition at 2 atmospheric pressure and 273 degrees Celsius. Provided that this data is not on STP, so first you will find the volume of oxygen liberated at STP. So you will use this equation simply, P1V1 upon T1, that will be equal to P2V2 upon T2. So P1V1, P1 will be 2 atm, right? And the volume is 500 ml and temperature is given as 273 degrees Celsius, means 546 Kelvin. So I am writing the 546 Kelvin like this. Now this data is to be converted into NTP. So P2 is 1, V2 is to be calculated, and the volume temperature is 273. So on solving this, what you will get, the V2 you will get will be 50 ml. So very obvious, 10 ml of H2O2 gives 50 ml on NTP or STP. You to be noted that 50 ml. So the volume strength will be calculated for volume strength of H2O2 will be calculated for 1 unit volume. So obviously V2 is 50 ml from 10 ml at STP. So it will be volume strength will be equal to 500. Sorry, this will be 500 ml. So this will be 500 ml. So we can divide this 500 ml by 10. What you will get as 50. So the volume strength will be 50. Right, 500 ml is the volume of NTP, and molarity will be equal to, again same, Vs upon 11.2, that will be equal to 50 upon 11.2, right? In the same way, we can calculate the normality, which is 50 upon 5.6 equivalent per liter, and the strength in the gram per liter, we will use the same formula, that 50 upon 5.6 into 0.034 for the gram per ml, and simply 50 upon 5.6 into 34 for gram per liter, right? You can take one more example. The 10 gram of H2O2 solution, 16% W by W of density 1.2 gram ml is given, and it is to find volume strength, molarity, normality and molality. So this is H2O2 solution 10 gram and it is labeled as 16% W by W. So first we can find the mass of H2O2, which is 16% W by W. So 10 into 16 by 100 and it will give 1.6 gram. Now we can calculate the molarity first, because we have the mass is 1.6 divided by 34, which is the moles, and the 10 definitely into 10 into 1.2 into, because 10 divided by 1.2 is the volume, that is mass upon density into 1000. This will give 1.64. So this will be the molarity, and we know that it is required to calculate the volume strength, and the molarity and volume strength is related is Vsm is equals to Vs upon 11.2. So Vs will be equal to 5.64 into 11.2. This will be the molarity of the solution. In the same way, we can proceed for the normality. It will be equal to Vs upon 5.6. So Vs will be equal, normality will be equal to Vs is 5.64 into 11.2 divided by 5.6. This will be the normality in equivalent per liter. Now it is required to calculate the molality. So to calculate the molality, it is required to calculate the mass of solvent. So W solvent in this case will be equal to 10 minus 1.6. This is mass of solution, this is mass of solute. This will be equal to 8.4 grams. So this is the 8.4 gram is the mass of solvent. So now how we can calculate the molality? So molality will be moles of solute, which will be 1.6 divided by 34. This is moles of solute present in 1 kg of solvent, so for 8.4 gram we can calculate is it will be equal to 5.6. So this is the way by which we can relate the volume strength of H2O2 with the other concentration terms. In the next video we will discuss the another typical concentration term, which is percentage labeling of oleum. Thank you very much.